Hey everyone, so today we're going to continue on the Anon board project that we started. Specifically, we're going to start creating the database configuration. So that means we're going to have a new package and a file inside of it, which we'll just call database.go for now. Package database. Before we get started, I think we should actually install the third-party packages. So what we're using is GORM, which is the Golang ORM. I think it's the standard one that most people use, but it's nice that there's a little copy and paste thing here, so we just... Oh no, that's not what I wanted. Okay, I guess I'll just highlight it. And we'll do the go get. Now we'll just check our go mod file to make sure that it's added, and it is at the very bottom. I'm unfamiliar with these linting errors, so I'm just gonna ignore them for now. But inside of our file, we're gonna do the same pattern where we create an interface for our database connection, as well as a private struct for our actual database connection object or instance. Now what we want inside of this is just gonna be the actual GORM DB. And since the struct itself isn't gonna be publicly available, we're gonna need to make a function here inside the interface that will expose the internal DB, which we're just going to call as get. And with all of that, we need a new function to initialize our database connection. So remember, we're returning the interface, not the actual struct itself. And I'm just going to start with the reference. And now this is where the errors are actually helpful. Because we defined the interface to have a method called get, we need to attach methods onto this database connection that'll satisfy the interface. So that'll be a function called get, and we're returning the pointer to the GORM DB. And most importantly, don't forget to attach this to the private database connection. And all we need to do here is return the DB that's inside of D. Okay, now we can focus on the actual new function, because we're gonna need to do a bunch of different configurations to get GORM to work. And just like the router that we did in the last video, we're gonna pass in the config object, which is the instance of Viper, and then we could get the actual Viper instance by doing a .get. I think before we go on, let's add to our config YAML file all of the options that we're gonna want inside of our database. And I'm mainly copying over from our Docker Compose file, which is on the right here. The username, password, database, host, which is going to be localhost because we're working locally right now. And then the port is 5432. And then I'm also going to add a log option for true. And this is mainly just for development reasons. But with that, we can go back to our database.go file, uncomment the config, and start using it. Now this might be a little redundant, but we're just going to grab all of the different configs that we just set. And with all of those, we're going to need to create the DSN, which is a URL type, where we have user, which is comprised of the user and password. Let me scroll down a bit actually. The scheme is going to be Postgres. Now the host name is going to be something like host:/port, but we're going to do a small little trick where we use the func package and do sprintf, so we can replace the string part with the host and then the digit with the port, and that'll give us the string localhost:5432 that we want. It's also worth noting that because of the way we set up our config in our production YAML, we'll need the same fields, and this will get the correct host for it. Now the path name is just the database configuration, and then I believe we need a raw query that takes in the URL values of SSL mode, disable, and we'll need to encode that. Now we can use the DSN to open a connection to GORM that takes in a Postgres connection that takes in our DSN string. And then let's handle that error. So if it exists, we could panic and just kill our server and say that database connection failed. And then finally, inside of the database connection struct, we can provide the DB inside of it with this DB. Now we did have another configuration that I added, so we can go ahead and get that boolean of DB log. This takes in a logger interface, so I'm gonna set that as a var, logger.interface, and then if it's true, we're gonna set that variable as logger.default. And that way, we could add that in the second argument of open, or GORM open, and that's a reference to the interface of GORM config, logger equals enable logging. Now we need to do this because this logger property is an actual type, not a boolean, so we can't just do config.getBoolean in here, as much as I would like, but Also, I need to go to the top to mention that logger comes from GORM. So we're using the GORM logger here and not the Logres logger that we've been using earlier. Oh, okay, I didn't get the Postgres driver. So we need to quit out of this, do a go get for the Postgres driver, and that warning should go away. So let's just go back to that file, and our linter is pretty happy now. Also, if you're wondering where I got this DSN from, because it's kind of just random knowledge to know that this is a URL type, you can actually find that on the docs, where during the getting started portion, right here, and it'll just tell you, okay, maybe not this one exactly, but the Postgres one, connected to database. Okay, I wasn't lying. But yeah, it's in here. Now back to the code. So I believe that's everything we need for this database connection file. We can go ahead and add it to our main.go, and we can instantiate a new database connection, which I'll name as con. So that's the package name and new. And remember, this takes in the config, so we'll just add the C here, and let's just add a spacer just for convenience. Now we're not using this yet, so I'm gonna comment it out so that the compiler doesn't yell at me, because the next step that we're gonna do is create our data models. And when creating our data models, this is also where we're gonna dive into the MVC architecture. So we could do something like domain-driven design, I believe that's what it's called, where we group up all the models into its own package. However, we'll use the MVC type, where each type of the MVC, so model, view, container, or not container, controller, gets its own package. So we'll do models slash thread. Yeah, thread. Okay. And this will be package models. Let's also create our reply.go. So these are going to be the two data models that we're going to have. Reply also needs the package models line here. And these are going to be the representation of the data that our REST API is going to be using. So I have the replies on the right and thread on the left. Now the data inside of this is not going to be too complex. We're just doing text and delete password as the most important parts of the model. Text is a type string, delete password is also a type string, and both of these fields are also going to be on the reply. Now if we go into the GORM documentation and go to declaring models, you'll see that the structure is kind of pretty simple. We don't need to add anything other than the go type, and everything will be handled for us by GORM. However, if we go down, there's other things that we can use. So by default, GORM model will give us all of these fields, and then let's go to some, okay, and then we can use it inside of a user struct like this. Now I'm gonna make my own model called basemodel.go instead of using the GORM model, even though the fields are not gonna be too different. So we're gonna have an ID, which is gonna be an unsigned int, and that's just default Postgres IDs, and we'll have a created date. And this is time.time. Now the only reason why I wanted to create my own base model is because by default, the Go types, or when they're serialized into JSON, they're still capitalized, but I want them to be lowercase inside of our REST API, which is kind of a very tiny nitpick, but it is what it is. Now, also inside of these data tags, you could add some GORM options, such as the ID is going to be the primary key for created. I want the default is to be now. Now we can reuse this in both of our thread and reply. So this will be base model, base model. Let's also add the tags here. So we lowercase everything. And then this is really of preference, but I'm using snake case instead of camel case. Not a huge deal. Also, to define the relationships, since a thread could have many replies, I'll have a field here called replies, which is the type slice of reply. And then the JSON, in addition to the name of it, we're gonna omit empty. So if no replies come back, it'll just not render the field. And then add the same thing for reply. We're also gonna add a field for reported, which is a Boolean. And this is where the two data models are gonna differ. So thread, in addition to these fields, we're also gonna have a bumped on field that's gonna be saying whenever a reply is added, the thread is gonna be bumped. So it's gonna be showed from recents. recency, I mean. Let's also just add some GORM options. So this will be default now, and this will be default false. And then for the delete password, we'll have not null, GORM, not null, default false. Let me just get rid of that so it's easier to see this. Okay, so now that we have our data models, we need to start talking about migrations. And if we go into GORM, there's a thing in here. I believe it's under migration, so let's go in here. So there's a method called auto migrate, which we could use in theory. However, this doesn't work on an empty database, and it also doesn't add the foreign keys, at least not for Postgres. We're going to be looking to another library called gormmigrate and use this as our auto migration tool. Now I also need to point out that there's this important note here. For the version 2 of GORM, which is the one that we're using, we need to get the v2 version of gormmigrate. So let's go back to our terminal and we'll do a go get on the v2 of gormmigrate. And now let's go inside of our database package where we're going to create a new file called synchronize.go. We could add it to the existing database.go file, but I felt like this is good enough as a utility function and not attached to the database connection class, as it were. But we're still going to need an input of the GORM DB. And before adding in all the options, this is going to be the idea of what this function does. So we're going to instantiate a new gormmigrate. This is going to take in a few parameters. One of them is going to be the database. And once we initialize it, we're just going to call migrate on it. The next parameter is gormmigrate.default options, and then it'll be gormmigrate.migrations as a slice of a pointer. We'll open this up, and then now we could just define struct literals of each migration. Now it takes in 3 fields: the ID, which we're going to use initial, and I believe this is a kind of a keyword ID for gormmigrate, and this will just do it at the very start. We'll also have migrate and rollback. Oh, I didn't call new. There we go. So I fixed all the syntax mistakes. I forgot the new here. I needed to return an error. As I was saying, migrate and rollback, they're both functions that takes in the GORM DB object, and we're using it as a transaction. And these functions just return an error. And what they're trying to do is set up whatever migration models that we're using. So the first one is we're gonna create a if statement here, where we run the auto migrate that I showed from the GORM documentation. In here, we're going to open it up and add the models that we created. There are the struct literal version of them. And this first one is going to create the initial database tables. The next one we need is going to be the one where we add the relationships. So we're going to add the foreign keys. And this is just raw SQL. Alter table threads, add constraints, foreign key, thread ID, references, threads ID. And that should work unless I misspelled something. And rollback, like most rollbacks, is we're just going to drop everything. We're going to drop the entire database. Drop table, and we're going to provide both the thread and reply. And these are literals, so don't forget the brackets at the end. Okay, I think that's everything. So what I'm doing is kind of a bad practice, as I'm just doing one single migration every time the server starts. And this is just to synchronize the models to be what we want it to be. When you have a more production style application, you're going to want to do migrations every time you make a change to the data model without destroying the data that you already have. So in that case, you'll have these migrations in a way that's not all happening in the initial one. So that'll just be another thing. You'll just do ID equals to whatever. And then also in that note, you'll likely add the model of that specific time here instead of referencing what's currently being used. Just so there's a log or audit of each new change to the data model. But with that, let's go into our database.go file and go into our new database connection. And at the very bottom, we'll just call it synchronize, and we pass in the DB before we add it to the database connection. This should be part of our config. So I'm gonna add another property here called sync. This way we'll only synchronize the database based on our configuration. Since, in production, this is probably a bad idea to do it every single time. So we'll hide it behind an if condition. So config.get boolean db.sync. That'll synchronize the database. Now I want to test this before moving on. So we're gonna go back to main, uncomment this out, and I'm just gonna do a print line of the connection just so it'll compile. We need to start our database. So for me, that'll be docker compose up-d for the background. For you, you might actually have a Postgres database locally, so you won't have to, you could skip this step in that case. Now we just do go run main.go, and the logging is on and the synchronize is on. So we should see go.sum missing entry for, am I missing something? Go run. There, what? Invalid field found in structs, threads, field, replies, needed to find a valid foreign key. Pretty sure I know what step I missed. So in the data model, we have threads referencing replies here, but what we forgot to do is in reply, we need to add thread ID, which is an unsigned int. And this is a GORM thing. The related model needs the relationship ID, but that'll fix the migrations. And also, while we're here, let's give it a JSON property. So if I'm correct, that should fix the go run problem. And there we go. And don't worry about this part up here. This is a log from before the database is synchronized. If you want to see that the database is synchronized and up and running, we connect to the database. First part is Docker specific. We're executing interactively on the container of PostgreSDB. The right hand side is the command that we're issuing inside of that container, which is psql with the username of Postgres and the database name of Anon. Now we're inside of psql, so we just do a dt to describe all the tables, which has everything that we expect. So we have the threads, replies, and migrations. If we describe threads, we have everything that we specified inside of our model. We also have the foreign key of replies, so Postgres knows that one thread has many replies. And then the same thing for replies, if we describe that. We also have the foreign key constraint as well as all the other columns. So that means we've successfully set up and configured our database portion of our server. We can kill this now and also down our Docker compose, make a git commit, and you will probably have a better commit message than me, since this is the YouTube branch of this repo. So this commit is just the second video. Git push origin branch name. Alright, so that'll be today. We finished quite a bit actually. We set up the database connection, our data models, as well as the initial migration to our stuff. The next step is going to be all the controllers, so all the routing and business logic. So that's something to look forward to. In any case, I'll see you all next time.